Okay, dear all students, very less students are joined, so only 60 students. What about remaining? Can we wait for again 2 more minutes? Okay, anyhow, they are under joining. So we will start our discussion forum at beginning. So whatever the students are asking, the questions, okay? So here, these are the 5 questions I got after from last lecture. So these are the 5 questions. Just I have to share with you. Okay. Dear all students, good afternoon, each and everyone. Am I audible and my screen is visible to everyone?
Yes, sir.
Okay, thank you. Thank you. 67 students are joining. So very less students today. I think maybe they have started celebrating Diwali now itself. Okay, anyhow, it's okay. So dear student, there is a 5 questions I got in these 2 to 3 days after my last lecture. So one question I got, sir, how we can find processors? Either it may be a single processors or multiple processors in the laptop. This is the one question. So I will answer you. In the second question, one of your good friend asking this question, sir, in the move destination source. So this one I make it with a different color code because it is a one instruction, move instruction with destination comma source. With destination comma source, what if we write the syntax just as move 0037H and we won't write any other register? So, okay, very good question. I'll explain you. This is second question. And the third question, one of your good friend asking, so whatever my notes is there, he took a screenshot and he is asking, uh, what he's asking. Okay. So in this, he is mentioning that move BL comma 4000 H. So what H indicates? He mentioned that what H indicates. That is his question. Third question, I'll explain you. And in the fourth question, one more student is asking, that is, sir, please repeat all instructions of yesterday's lecture. Okay, I will give you the solutions for you, no problem. And at the last question, in these 3 days, so what is the use of 8086 and 8085? So these 5 questions I got from SYBTech student group. Fantastic, really a good questions for this. So now we will go one by one. So dear all students, at the first question, I think already I explained. One of the student is asking this question, but in some other way is asking same question. How to find the processor in a laptop or in a desktop computers. So here I will show you on that day, at the date of, I think I remember 20th date. Maybe it was there. In the date of 20. I think it is not in the date of 20. Maybe other date 20, 28, 10, 21. Maybe it is there. Okay, in this also it is not there. So just I will look into that your group. Uh, that is yes, microprocessor group. First one PDF I have to send it out. So what happened? There is a network problem. I think maybe. Okay, fine. Here microprocessor in this group. I send that first PDF. What is that first PDF? We started in here. So at the date earliest 10/14. Okay. So here I think which first that yeah, this is the thing. So in this I have to explain it you clearly. So please remember who are asking this question. Okay. So no, this is not there. Yes, fine. See, the question, first question for the today's discussion forum, 1 November 21. The first question, how to find the processor in a laptop. So this question, just you compare with this question, already one question asking on the date of 14/10/21, how to recognize or check whether the Intel core processor or dual core processor. So it may be a processor means one processor, we call it as a single processor, and two processor, we call it as a dual core processor, and four processor, we call it as a core to duo processor, quad core processor. So quad core for four, dual core for two processor, and one processor is for just a Intel core processor. So it's a single processor, two processor, and four processor. This question already I explained you. So again, I'll explain you. Please, you check it out in your laptop if you are not getting on that day. So here, first what you will do, you will open the taskbar, task manager, then go to the performance. After that, you will see this one. We say it is a taskbar. Okay. So everyone, please observe this bottom. All icons are there. This one we call it as taskbar. Right click on that. So in that right click, you have to move to task manager. So this is the task manager. Everyone, I think all of you visible, right?
Yes, sir.
Hello.
Visible.
Okay. So here, go to the task manager. So this window is opening. This window is opening. In that window, again, what is my second step? Go to performance. So this is the performance window. Click on this performance. After that, you will go to CPU tab. So this is the CPU tab. Click on that. So I make it as uh, big big screen. So in this it is clearly available that there is a types of number of cores. So what is this number of cores? Is nothing but what? So my laptop is dual core is there. My laptop is dual core is there. That's what two processors are present. It is showing two processor. So some laptops it is showing a if with this number is one means that is a single processor. So it is showing two means my laptop is having two processor, and if it is showing four means the course is nothing showing four means that is quad core. So in this way you have to find in your laptop either it is a single core or a dual core or a quad core. Okay. So already I explained. Still also I will given the demo to you. So dear students, please you check it out. I think I cleared your answer. Who are asking this question? In this way, you have to check it out. Just simple step, go to taskbar, task manager, go to the performance tab. Under that, you go to the CPU tab. This window is opening. I shaded here with the different colors. That is, course is completely visible, the number of course. Okay. So like that, please, you have to find out the number of cores present in your systems. How can find the processors? How we can find the processor, either single processor or multiprocessor? In that way, you have to find. So I think I explained. Am I clear? So please reply me who are asking this question. Either it may be text or it may be by voice. Okay. Next, I will move to the second question. One of your good friend asking this question. The question is, sir, in the move destination and source, move comma destination source, what if we write the syntax just as move 0037H? So actually the format is you have to write one of the instruction move. After that you have to write destination register. After that you have to write source register like this. But here in the question, what you mentioning move comma 0037H, it means that just you are passing the value, just you are passing the value, but you are not giving any memory location to store that value. So you are not giving any memory to store that value. That's what it will give the syntax error. So that's what I said here. It will give the syntax error first of all. Okay. Answer. It will give syntax error. It will give syntax error because it will give syntax error because 0037H is a value. You move from the where to where. That is the question. Because it is not finding any destination or any source point for this storing and transferring the value. That time, because of not getting any memory, it will give the syntax error. Syntax is destination and source must and should there with the move instruction. With the move instruction, destination and source must and should be there. If it is not there, then there is the fault format of instruction. That's what it will give syntax error. So for that, always you have to use move instruction with the destination register and one value or source register. You have to use, for example, move ax comma 0037H you have to use. H is in the sense it's the hexadecimal value. So this means that the 0037 hexadecimal value transferred it into AX register and stored in the AX register. That is the answer to your question. So, dear student, I think I cleared your answer. Please give me reply if you understood or not understood, please. So, next third question. So, next third question. Can I move to third question? So, I'll check it either they are replying. Got it, sir. Yes, okay. One question I answered. Please, second question. Please, second question. Reply me who are asking the second question. Okay, now I will move to third question. So in this question, he is asking in this my notes page in the move BL square bracket 4000H. So what is his doubt is actually 0037H, that is a one of the value which is a hexadecimal value. That's what we have to mention with the H indicated by hexadecimal of 0037H. That is right. But in second case, move BL 4000H. अभी इसमें कैसा है 4000H, in the sense it is an address, right? Memory address. So in microprocessor, memory address also you have to indicate it by hexadecimal. No problem. How you have to indicate it by hexadecimal? Just one example I have to given. So H in the sense hexadecimal for his answer. So after that, for example, अभी हम लोग ये beginning address we select as a 000H. H in the sense hexadecimal address number it is. And next value हमको क्या होता है? That is 01H होता है, 02H होता है. With the continuation of somewhere it may present 39999H, which is a continuation of from the 0 memory address with a hexadecimal memory address. It is reached to 099H. After 0999, it will comes 4000. After that 4001. And at the last address is FFFFH. So beginning address is 0, last address is H. In between any of the number hexadecimal you can use, that is possible. So that's what we have to use H, where 4000H we are using in this way. Okay. So Abhi, I think I cleared third question. Next, who are asking that question? Are you present today? So next, I will move to the fourth question. I will move to the fourth question. So, sir, please repeat all instructions of yesterday's lecture. Okay, last lecture, I explained 10 instructions, all the data transfer instruction. So, my dear student, one my apology to you. So, within a short period, I will explain you. Within a short period, I will try to explain you within 1 or 2 minutes. If you need complete explanation, if you need detail, if you need detailed explanation, please you make a one schedule at 6 p.m. today and send me one Zoom link. One Zoom link. I will explain you through that Zoom link, because if I have to completely explain, again it takes minimum 30 to 40 minutes. So because for the one student, simply we don't use all students' time. So for that, at the 6 p.m. you have to call me and I have to discuss. And among with you, any of the other students also have a doubt, I have not understood, please all of you have to join at 6 p.m. 6 p.m. to 6:30 or 6:40 p.m. I will explain all remaining instructions. So please you cooperate me. Instead of this unnecessarily we don't use others time also. Okay. So any of the students you have to join at 6 o'clock today. Either you send me a link, otherwise I'll send you a link. Okay. So even though 1 2 or 3 minutes in a short, I will explain you now. I will explain you now. No problem. Okay. If you need huge explanation, please you go through the at 6 p.m. Please you cooperate me regarding this, because I want to cover syllabus also within a stipulated time. Please, I need your cooperation. Such kind of things, but more extra time I will schedule and I will explain you for that. Okay, dear student. I think please you understand the situation. Okay, it is my request. So next, One more question I got at the last question for the today's discussion. So, what is the use of 8086 and 8085? So, dear all students, the 8086 and 8085, it is a just instructions. It is a just instructions as per human being convenient. We have to prepare some instructions as per our usefulness, and we have to write the programs like C programming, C++ programming, Java programming, .NET programming, Python programming, like that. This is also one of the machine instruction language. 8086 and 8085 is a machine instruction language. Already I explained you how 8086 names is comes and how 8085 names is comes. All of you aware of that. Already I explained. You go to previous discussion for forum questions, you will get it. Okay, so here the question, what is the use of this? So this is use is nothing but whatever you are finding the uh, you are studying a programming language, all the programs whatever you have to get the output, like that C language, C++ language, Java language, .NET language. This is the one of the language. That language we call it as assembly language. This assembly language is totally, that is machine instructions. And actually this machine instructions language, in which field actually you are using means you are using in the game devices. So in the olden days all of you use the game, right? That videocom game is there. In the olden days that games you have to use it, and now also in a laptop, in your mobiles you have to use the game. All those games are mainly developed by the microprocessor. And second useful is, in the mobile phones almost 80% of things is going to be used by the mobile phones. So in the CS background software, just you have to use it one software, but entire that hardware part is connection between the software and the hardware part. That microprocessor will only the work behind this screen. So microprocessor you have to use it in the mobile phones, you have to use it in the laptops and electronic gadgets, some electronics goods also. You have to use it this 8086 and 8085. So and also you have to use it to control the topic lights, that is topic lights controller. So the signal lights, to controlling a signal lights, the majority of the things, that is microprocessor technology only there, that is 8086 and 8085. So software is also a one part, that is secondary, but entire the hardware part and software part connection is going to be happen, no? That is going to be do with the microprocessor. Okay. So next one is washing machines. In washing machines also you have to use the microprocessor. Microwave ovens also you have to use the microprocessor. Frequency counters and synthesizers in a clock frequency, AC signals, digital signals, you have to use this microprocessor. And digital clocks also you have to use this microprocessor. Not only these, just these five to six I listed, plenty of applications are there, plenty of applications, plenty of usefuls are there. अभी कई जगह में हम लोग 8086 and 8085 यूज करते हैं. एंड अभी अभी वो कैसा है, वॉट एवर द इलेक्ट्रॉनिक्स थिंग्स आर गोइंग टू बी डेवलप्ड, that is connection between software and the electronics goods, hardware part and software part. Majority of the time we have to use 8086 microprocessor only. Okay, so dear all students, I think today's 5 questions I got. So is there any questions apart from this? Please, can you remember or can you please? So this is the questions. So this one fourth question is, I will make you schedule at 6 o'clock. Call me and you got explain from me. And within a short minute, 5 minutes, I will explain now also. Don't worry. Okay. So I'll check it out in the message stage chat. Is there any other questions? Okay. Okay. One student saying yes. Okay. Yes. Fine. Another student also, he got answer. Okay. Fine. So, okay, I think those are understood. Thank you for your reply. So, and this is the open discussion forum session today's. So now I will move upon actual syllabus. uh, from last lectures. So as per your one of the student asking that previous instructions with a short, and this one I'll share with you. Okay, first I'll share with you. Please, all of you go through this. That is 111. Okay, just a minute. I have to attach this in the microprocessor. So microprocessor. So I will take A and B. So here I will attach uh, today's discussion forum WordPad. So that is desktop. So here 111. Okay. Okay, dear all students, I think you got that WordPad. Today's discussion forum WordPad. Please you go through this. So apart from this also, if any questions, please ask. I'll give you 2 more minutes. Up to 12:50, please. Any more questions? Otherwise, I'll move to actual syllabus. Okay, no more questions, I think. Yes, fine. Thank you for the questions, and thank you who are asking these questions. Too much thankful to you on behalf of all your friends also. Because of you asking, your friends also come to know all those concepts. Okay. So dear students, now I will move upon next. So dear students, yes, okay, dear students, last lecture we taught about this instructions, data transfer instructions. So what are the different kinds of instruction? First, data transfer instructions. Next, it will comes input output instructions. After that, it will comes direct and indirect instructions. After that, it will go given that jump instructions. One by one, we will study. But in the last lectures, we will study this data transfer instructions. Just within short minute, 2 to 3 minutes, I will explain you in short. As per one of the your student is asking, we have to make a schedule on at 6 o'clock today. Please, any of you not understood, come and join. Okay. So in short, I will explain. First one is a move instruction with a destination and source. So the whatever I have to mention here, these are the format with a particular instruction. Wherever you have to use the move instruction, that time compulsory you have to use destination and source. Otherwise, it will give the syntax error because this is a fixed format, and wherever you have to use push, that time you have to compulsory use the source because from the stack you are going to do the manipulation. And wherever you have to use the pop operation, pop instruction, that time compulsory you have to use the destination. if somewhere you have to do the work, that is nothing but a destination होता है, उसके लिए अब पॉप के साथ कंपल्सरी डेस्टिनेशन यूज करना ही है, पुश के साथ सोर्स, पॉप के साथ डेस्टिनेशन, ये दोनों भी वैसा अपोजिट रिलेशन में हो जाएगा. सो नेक्स्ट वन इज पुशअप. Same way with the push instruction, just you have to use the flag. So if whenever you are using the flag means in the flag whatever the values are there, either it may be a zero value or it may be a one value, enable or disable, or we have to say high or low. High means one, low means zero. So these are the fixed value. So for the push up, push flags you have to use, and pop if pop flags you have to use. For here, no need of source and destination because already the flags is having a fixed value. Okay. So next one is the XCSP, in the sense it is the exchange, destination and the source. So it means that you just swap the value between source to the destination and destination to the source. Transfer destination to the source and source to the destination values. Okay, that is exchange. So and this exchange with the uh, base register, in the sense there is no need of destination and the source because this beam, in the sense base register is already present to the transfer. So the base register you are going to be do the transferring the data. That's what here don't need of destination and the source. So last next one, load effective address. In the load effective address, that effective address is the thing, but it is going to be carry the work in the accumulator. So that's what you have to use source and register. So in the destination point of move, you have to use the register, particular register, and you have to use source as like in the move instruction. Only instead of destination, you have to use register here. Okay. So in the next loads with the a string value, loads with the effective string value. Here also you have to use destination, register, and source. All these three operands you have to use in LDS. Okay. So last that effective string in the sense, again same you have to use destination, register, and the source. So these all are we covered in the last lecture. So please all of you go through it and entire that explanation I have to given you already. So here it will there. Okay, push F. So what's the last? That is LEA means load effective address. This is the loads the register. So please make a mute if you don't have any questions. It is my request. So here in the loads destination register, you have to use three, that is destination register and sorry, destination register and source you have to use. Same way in the LES, that is loads the destination with the ES extra segment register, that is destination register with the source you have to use. LES and LDS both are nothing but a loads register. Both are nothing but a loads destination register. LDS is in the sense destination register. LES in the sense extra register. That is extra register. You have to go through it. So this is coverage of last lecture. So now I will move to the next instruction. This is all about data transfer instruction. Next, I will move to second instruction, IO addressing modes. IO addressing modes of 8086 instruction. IO addressing modes of 8086 instruction. Dear all students, can I start now actual class? Am I audible and my screen is visible to everyone?
Yes, sir.
Yes, sir.
Okay. Okay, dear all students, I need your cooperation because your cooperation is also very, very important. Please, all of you be concentrate on this each and every instruction. So, if we have a time at the last today's lecture, within 10 or 15 minutes, I will give you one demo how to execute the programs. So, as I think all of you are installed that TOSM software, but who are going to not install, please you installed it. If we are getting a time, we will execute one program, one basic simple program. Before that, I will move to IO addressing modes 8086 instructions. So in addressing modes, input and output addressing modes, you studied some direct addressing modes and indirect addressing modes. Okay. So just 1 or 2 minutes, I will take that direct addressing modes and indirect addressing modes. So here in the addressing modes of 8086, it can be either 8-bit or 15-bit. How it is 8-bit or 15-bit? For the 8085, it is 8-bit. For the 8086, it is 16-bit. And in that, there are two types. First one is direct addressing modes, and the second one is indirect addressing modes. So again, in the direct addressing modes, what it will do? Directly you have to transfer the values to the register. Directly you have to transfer the value to the register. That one you said is a direct addressing modes. Direct addressing modes. That particular value address is going to be stored in a particular register. That is nothing but direct addressing modes. So if we have to use 8-bit IO address, we get a range of 0 to FFFFH. For the 8-bit, only two digits, 002, 00001, 002, 003, like that, up to FFFFH you have to taking. If it is a 16-bit, then you have to use 256 ports. You have to use 256 ports. That IO address is specified in the instruction. For example, there is a in all AL in the sense what there is a one accumulator low register like BLCL and BHCH. So here we have to use it for the no label with the register is A, that's the accumulator register, which is having a value of 80 hexadecimal. 80 hexadecimal. It means that the 80 hexadecimal value is going to be take inside of AL accumulator, that is with the instruction in, that is input instruction. In is the thing but what? It is a input instruction. Our heading only input and output addressing modes of 8086 instruction. So in that you have to use, this is the in instruction format. What is the in instruction format? In we have to use it for mnemonics, and the operand one we have to use it for the AL register, accumulator register, and the 80H is nothing but it is a hexadecimal 80 value. So this 80 value is transferred it into AL registered and stored in the AL register by the help of in instruction. So it means that AL gets data from input and output ports address of 80H. Okay, that is the meaning. Complete meaning I have to given in the sentence only. So in this second, that is, it is also called fixed port addressing because in is the fixed port addressing. So this one we have to say indirect addressing modes. This one we have to say indirect addressing mode. That the mnemonics, that instruction is nothing but in, in. Same way in the indirect addressing mode, in the next one indirect addressing mode, if we have to use a 16-bit IO address, we get a range of 16-bit means 4 bits, that is 0000H, and at the last value is FFFFH. 0000H to FFFFH range, we have to use it in the 16-bit IO addresses. And later on, this gives a total of 2 raised to 16. That is 16 means how much you will get it? That is 65536 ports. So in the direct, just you have to use it 256 ports, but in the indirect, you have to use it 65536. That much number of ports you have to using, because 2 raised to 16 in the sense you have to getting this much number. 2 raised to 8 means you have to getting this 256. So here in this IO address is specified by a DX register, data segment register, that is move DX 2000H. What is the meaning of this? DX is a destination, 2000H is the source. So the source value is instead of register, directly we have to take the value. What is the value? That is 2000 hexadecimal value, transferred it into a DX register, destination segment register, or memory register. So that is the meaning of move DX 2000H. How you write in that? Indirect. So here in the first one, direct addressing modes, you are directly transfer the value 80H to the AL. But here you are indirectly transfer the value of DX to the AL. What is DX? DX you have to mention here 2000H address. That address is transferred through the DX register to the accumulator. 2000H is direct, you transfer through the DX register to the accumulator. That's what it is saying, indirect addressing mode. Got it my point? 2000 is transferred to the DX, and whatever DX is containing that 2000 value, that is transferred to the accumulator. So 2000 indirectly transferred to the accumulator. That's what we have to say. This is the indirect. But in the previous example, the ATH is directly transferred to the accumulator. For that, we have to say direct addressing mode. For say direct addressing mode. So here in the second one, 2000H is indirectly transferred to the accumulator through the DX register. That's what we have to say. This one is an indirect addressing mode. So in the input and output, direct and indirect addressing mode. That is in, you have to use it. Okay. So in this, in the in the instruction, this one you have to say destination, and the next one you have to say source. So destination register is nothing but the accumulator, and source register is nothing but a DX register, data segment register. So for that, the loads the destination register with the contents of the IO ports specified by the source, and the source, whatever the source is containing this value, it is an IO port address. Source port is nothing but it is an IO port address. If the address is 8-bit, it will given by a direct address modes. So as you saw in this, if it is a 8-bit, you say it is direct addressing mode. If it is a 16-bit, you say it is an indirect addressing mode. So in the in instruction, input and output instruction of in destination register and source port, what it will show the source. So अभी ये source में क्या हो जाएगा? Source में अभी ये bit register है तो we have to say indirect register addressing mode. अगर इसमें 16 bit है तो we have to say that we have to say indirect addressing mode for the 16 bit, and we have to say 8 addressing mode for the 8 bit, direct addressing mode for the 8 bit. So it is the address of 16 bit, it will be given by the DX register using the indirect addressing mode. So indirect means 16 bit, direct means 8-bit addressing modes. So in the destination, that is accumulator, it means that if it is 8-bit, then you have to use AL or AH register for the 8-bit, and for the 16-bit you have to use AX in general. X in the sense what? Either it may be AL and AX both. So for the 16-bit you have to use general as AX. For 8-bit you have to use AL and AX AH register. Okay. So like that you have to use in the source, destination, and loads. What is the loads? Loads is nothing but that's the in instruction. You have to use loads in the destination register and the source port. Source port 8-bit means direct, 16-bit means indirect, and destination 8-bit means either it may be a AL or AH. If it is 16-bit means you have to use instead of AL and AH, you have to use AX register. So some ठीक है. So next, for example, in this whatever I explained, we will understand with the example. In is an instruction for the input, and AL is the accumulator at the position of destination, and ATH is the value. So first two cases, these are the direct addressing mode. In these are the direct addressing mode. First case is for the 8-bit because it is AL or AH, and second case it is the AX in the sense what? It's a 16-bit. So 80 value you transferred into the AL with the 8-bit, and in the second case 80H you have to transfer into the AX. So AX in the sense it is a 16-bit. Okay. So like that, these first two are direct addressing modes, and the next two are indirect addressing modes. Same value you transferred through the DX to the accumulator with the 8-bit, and in the last one that is with the 16-bit because of AX. So indirectly you have to transfer the value. That's what these last two are indirect memory address, and first two are direct memory address. Okay. So like that you have to use the in port, that is input output. This is all about in. So next I will move to the out destination port source. So out also you have to specify the same thing, but in the in, please all of you carefully observe, in the in, destination register is there and source port is there, but it is reverse in the out. So destination becomes a port, in the out destination become a port, and in the source it is the source become a register. It is reversed in as in the in. So here register and destination, but in the out it is port and the register. Okay. So remaining all are same. So in this out means what? You are going to be get the output from the particular register. Whatever the register is containing a particular value. अभी एक register में कोई तो value मिल गया, वो values we have to get from the output. So in the if something there is a 80 value is present in the accumulator, so what are the output instruction? from the accumulator, we have to transfer the EAT value to the out instruction, and that EAT value we have to get at the output uh, for the 8-bit, and same way EAT value output for the 16-bit. This is the direct values. This is the direct addressing modes. And in the indirect addressing modes of out instruction, that is AL value. So AL value, again you transport it into a DX register. From the DX register, you have to get a particular value. Same way, it is in the 8-bit, third one is in the 8-bit, and fourth one is the 16-bit DX. Okay, so that is AX and AL. So here this is indicates the AX is nothing but 16-bit and AL is nothing but 8-bit. DX is the destination source point. Okay, so this way you have to use input and output memory addressing modes of 8086 instructions, input and output. So once we have to use all these instructions, so today I have to I explain you two instructions. That is, one is the in instruction and one more is the out instruction. So up to now I explained total 12 instructions. So all these 12 instructions while we are using in a programming concept, that time you will clearly understood. That's what. So today's class onwards, we have to use one program practical session along with the theory class. You get more clear on that. Okay. So please, any doubts in the in and out instruction? Very simple. In and out instruction. In instruction, two inputs. Sorry, two 8-bits and two 16-bits. Same way in the out instruction, it is opposite. Just source to the port, destination point to the port, and port point to the destination. Reverse it. It becomes a out instructions. So please, any doubts regarding these two? So if no doubts, then I will move to the next instruction. That is third kind of instruction. So up to now, two main category of instructions we have to study. One is data transfer instruction, and next one is input and output addressing modes 8086 instructions we studied. Next to the third point, third category, I will move to the program execution and transfer instructions. Program execution and transfer instructions, I will move to this third category. So these categories are mainly, we called it as again sub categories. Near branch, first category is near branch. So the instructions are called branch in the program sequence. There are two main types of branching categories of instructions. First instruction, that is the branch instruction, and the second instruction, that is the for instructions. That is a for branch, near branch, and for branch. So in the format of the instructions, you saw that at the beginning it is a branch, after that mnemonics, after that operands, after that you have to use the values. At the beginning, come to this point, as earlier what I say, this one. So at the beginning is a branch, right? This is a branch. After that, you say BR means label, provides the meaning of branching to this instruction. Next one is instruction. What is instruction? Add instruction. It may be a mnemonics. And the last one is AX with the operand one. And this is the source. AX is destination and count BX is the source. And this is the comment line. So this way. So now we are going to be branch. Okay. So in the branch, there are two types. One is near branch and one more is for branch. So totally अभी इसमें भी दो कैटेगरी का है. वो पहला होता है कि नियर ब्रांच एंड बाद में होता है कि फॉर ब्रांच. So in that, program execution and transfer instructions, third category. So in this, first I will move to the near branch. So near branch means what? Which is going to be present along the sequence of instructions one by another, near to the calling and call by. So that one you have to say near branch. This is an intra-segment branch. Intra-segment means inside. Inside. Near means inside. And the for is nothing but a outside inter-segment. So first one we will take that near branch. So in that, this is an intra segment inside the branch. That is, the branch is to new location within the current segment only. If we have to call the current segment values, current segment branch, that one you have to say near branch. That one you have to say near branch. So that is the range between 120 minus 128 to 127. It means that totally 256 characters for the 8-bit. That one you have to say near branch. And also you call it as short branch. Near branch, one more name, you call it as a short branch. So in second one, that is a for branch. So in that for branch, this is an intra-segment branch. Intra-segment means outside. First one is inter-segment, inside. That one we call it as near branch, but this is outside. So for that we say it is a for branch. So in this for branch segment, it is the branch is to a new location in a different segment. If that branch location is in a different segment, that one we have to say for branch. If it is the same segment or current segment, that one we have to say near branch, for branch and the near branch. Okay. So this is about that program execution transfer instruction. While going to use the branch, it may be a near branch or it may be a for branch. Near branch means intra segment inside with the current segment, and for branch is nothing but it is a inter segment or outside with a different segment. So these two are program execution and transfer instructions. So along with that, we have to, along with the branch instruction, we have to use jump condition. We have to use jump statement. So as you already know, jump used in your C programming and somewhere in the data structure also you have to use it. So what is the meaning of jump? It will jump from one place to the another place in the program. If that is jumped from one place to the another place, your controller within a segment, that one is near branch jump. If it is jump from one place to the another place with a different segment, that means for branch jump. So in that jump, again there are two main categories. Yeah, just already studied in the addressing modes. So jump in that intra segment jump and inter segment jump. Intra segment is near jump, inter segment is for jump. So again in the intra segment there are two types: intra segment indirect jump and intra segment direct jump. So again here in the inter segment, again here also two category, that is inter segment indirect jump and inter segment direct jump. So in the jump, totally there are four categories. For the intra, two direct and indirect, and for the inter, again two direct and indirect. Okay. So this is your jump conditional statements. So in that first one, we will see that intra segment indirect, intra segment jump direct. Sorry, intra segment direct jump. First one we will see this one. After that we'll go for intra segment indirect. After that we'll move to next these two. So first one I will move to the intra segment direct jump. So what is direct jump? It is a direct jump in the sense what it is near. Okay, it is a near to that within a segment. So here in this, the new branch location is specified directly in the instruction. New branch location is specified directly in the instruction, that is for the intra segment direct jump, and the new address is also calculated by using this adding of either a 8-bit or a 16-bit displacement to the instruction pointer, and that code segment does not change. The code segment is remaining same in the intra segment, and a positive displacement means the jump is ahead in the program, and the negative displacement means the jump is behind. Positive means ahead, आगे. Or the negative in the sense behind means पीछे. So go for backside and go for front side. We have to decide by the positive and the negative displacement. So for example, so here with a clear example I given to you, jump previous. Previous means what? That is instruction point offset address is of previous. Previous is uh, uh, ahead, and same jump with the next. Either you go to the next or you go to the previous. That's what the jump instructions uh, we have to nominate by like this. Either jump previous or jump next. If your cursor is goes to somewhere in the program code, that time you have to use a jump next. Either your program cursor is come to the beginning to the to that particular point, then you have to use jump previous. That is offset address of previous and offset address of next. This is about intra-segment direct jump. So next, same intra-segment indirect jump. Indirect jump means jump one place to another, from that place to again somewhere. That is indirect. So here the new branch address is specified indirectly. Here it is directly. So, but in the intra-segment indirect jump, the new branch address is specified indirectly through the register or a memory location. Through the register or a memory location, that's what it is showing, indirect jump. And the value in the instruction pointer is replaced by with the new value, and the code segment does not change. So in the intra, either it may be direct or indirect, but the code segment will not change. Code segment will not change. For example, in the intra segment indirect, that is, if jump word, there is a one word of the pointer bx. What is the bx register? Which is having the address of this bx register is nothing but a pointer that is going to be given to a word register. That is a jump from word directly this base register to this particular word. That is a indirect intra segment. So in this, the instruction pointer of the data segment with the bx register bx, that is base plus 1 with the transfer to the instruction pointer. So that is the main function of jump instruction. Okay. So again, the third point, intra segment. Sorry, inter segment. First these two are the intra segment, and next these two inter segment direct jump. So in this inter segment direct jump, the new branch location is specified directly in the instruction. Both code segments and instructions pointers are get a new value. So here it is changed, because if you get the new value, assume the next segment is label pointing to an instruction in the different segment, that is jump next segment. Clearly we have to use jump next segment in the intra segment direct jump. We have to use the instruction jump next segment. So here, that is the uh, code segment and the instruction pointer. Both are get the new value from the label with the next segment, because at the outside the segment is nothing but next segment. That's what it both are getting a new value. Get the value from the label next segments. So that's in the direct. So in the inter segment indirect jump, that is the new branch location is specified indirectly. The new branch location is specified indirectly to a register or a memory location. So a register or a memory location, we have to specify indirectly to the new branch. That one is nothing but indirect inter segment. So in this also again both code segment and instruction pointers are getting new values. For example, that is a D word, data word. This is D word in the sense what? Data word. Previous directly we have to use the word. Here we have to use data word with the pointer base register. Same way, just instead of word we have to using B word, data word. So this is all about jump instruction. So again, in the jump instruction, there are four types. What we saw the different categories. Okay. So dear, also just you have to make a list out of all the instructions and one by one, just you have to recall. Whenever you are going to stuck, that time you have to use these notes. It's more benefit for you. So today's what I covered, uh, input output instructions I have covered, in instruction and out instruction, and also I have to cover program execution instruction, either it may be a direct or indirect, and inter or inter segment. So inter segment direct, inter segment indirect, and intra segment direct and intra segment indirect. So totally, this 4 plus 2, 8, 6 instructions we have to study by the today's lecture. So by the today's lecture, just 6 instructions we have to study. And in the previous lecture, we studied 8 instructions. 8 plus 6, totally 16 instructions I have to cover. All these, please make you mute. So all these 16 instructions are very important for your practical point of view. So next we will come to the J conditional. That is J conditional jump instructions are there. So here in that J conditional jump instructions, I have to make it as a some categories. That is in the J conditional jump instructions, this is a conditional branch instruction actually. J condition in the sense what? It's the conditional branch instruction. If condition is true, if the condition is true, then it is similar to the intra segment direct jump. If the condition, so wherever you have to use the condition, no? If the condition is true, then it is similar to the intra segment direct jump. If the condition is false, then it becomes a branch does not take place. Next sequential instruction is to be executed. False in the sense it is going to be fail. It is not going to be executed. And the destination must be in the range of 256. Total 0 to 256 in the sense what? Minus 128 to plus 127. Totally it is a 256 range. And from this address of the instruction, it is only short jump and long jump we have to decide. So in the jump JNC, jump on no carry. Next, that is jump next if jump next if carry flag is not set, various jump instructions are as follows. So here for all the jump conditionals, we have to make one list with the carry flag, because entire this jump conditional statements are depends upon carry flags. Either we have to learn totally 5 carry flags in the 8085 and 9 flags in 8086, right? All those flags are based on jump conditional, based on this working with a jump conditional. So here I have to mention CF means carry flag, ZF means zero flag, PF means parity flag. So all you just record it, whatever 9 different flags you studied. So in the mnemonics, that in mnemonics is nothing but a name of the instruction. JC means jump on carry. JC means jump on carry, which is a, if it is carry flag is 1, then it is going to be jump. Then it is going to be jump it. Otherwise, second instruction JNC, jump on no carry, that is not carry. JNC in the sense what? Jump on no carry. JC means jump on carry. So JNC, jump on not carry. If no carry, then CF flag is becomes a 0. If it is carry, then carry flag is 1. So next third one in that category, that is jump on equal or jump on 0. So JE in the sense what? Jump on equal, or JZ in the sense jump on 0. If it is equal and 0, whenever the 0 flag is 1. Otherwise means If not equal and not zero, jump on JNE, jump on not equal or jump on not zero, then the zero flag is becomes a zero. If it is zero flag is zero, then no equal and no zero. If it is one, then it is a equal and zero. So next fifth one, parity flag. It is depends upon the parity flag JP. It means that jump on parity, jump on parity. That is or jump on jump on even parity, jump on parity or jump on even parity. That time the parity flag is going to be one, then only it becomes a jump on parity or jump on even parity. The next one, J and P, jump on no parity, jump on no parity, or we say jump on no jump on odd parity. It means it is a jump on odd parity. Previous is a jump on even parity. Next one is a jump on odd parity. So that the parity flag is one or zero. Zero means no parity. One means parity or even parity. Okay. So in this way, they have to build the, and these are the common operations wherever you have to use all these instructions. Okay. So dear all students, you may get difficulties because now only this theoretical part is going on. Actually, these all the instructions we have to use it in the programming practically. That time the real particular instructions used for what purpose, that one you are going to be understand it. Okay. So next, the seventh one, JB or JNAE. It means that jump on below. Jump on below means again the carry flag is one, then the jump on below is enabled. Otherwise, if the carry flag is zero, that is jump on above. JAE means jump on above or equal. Jump on above or equal. A means above, E means equal. First one is that is JB in the sense, B means below. Jump on below. Below you are going to be jump it or you are going to be jump above or equal. That time you have to use JAE instruction. That is again depends upon the carry flag, either 0 or 1. So the last instruction, jump below or equal, JBE. First one is JB, just is jump below. Otherwise JBE in the sense jump below or equal. Otherwise jump above. That is a jump above. It means that jump below or equal. So these are used for carry flag or X or Z flag, zero flag. Carry flag, X or Z flag, it may be 1 or 0. So these are the unsigned operations. Last four are unsigned operations. Is there any message I have to get in? Yes, fine. So that is jump on uh, below enable or jump above. These two are based on carry flag XOR with the ZF flag. Either it may be 1 or 0. In the reverse operation, it will going to be work. So this is about your jump instructions. It is actually no need of in depth. Just you have to use these instructions. Remember these name of the instruction and use it for below, above, equal, parity, non-parity, and equal, non-equal, zero, carry, like that. You have to just remember. And this is the name of that useful, and this is the based on the flags it is going to be works all the jump conditional instructions. So next 11th one is JO in the sense whenever the overflow is occurs, whenever overflow means once the stack is full, again you are going to be entered a value into the stack, that time overflow is occurs, that overflow flag is one. The overflow flag one means that is the overflow of stack condition. That time we have to use it JO, overflow. Next J and O in the sense what? Jump on no overflow. First one is jump on overflow. Second one is jump on no overflow. No overflow means overflow flag is zero because no overflow. Same way, you have to use it for the sign also. JS means jump on sign, jump on sign. Either it may be positive or negative. If the sign flag is 1. If the sign flag is 1. Otherwise, jump on no sign or not sign if the sign flag is 0. So once we studied that all the flags set in the unit number 2, that time I am saying all these flags are useful in the unit number 3 in that practical sessions. So now you have to use all those flags wherever it is 0 or wherever it is 1. So JNS means jump on no sign. No sign in the sense sign flag is equal to 0. So next the instruction uh, JL jump on less or jump on less or jump on negative equal. Jump on negative equal in the sense what? The sign flag XOR with the overflow flag. Sign flag XOR with the all of you know the condition, right? XOR, the truth table of XOR get is used for what? So the sign flag XOR with the overflow flag is 1. That time we have to use JL or JNGE, non equal or negative. So next one is jump on uh, greater or equal. So JNTE means jump on no greater or equal. Only jump on less. Here JGE means jump on greater or equal. Otherwise jump on no less. Jump on no less also you have to call, or jump on greater or equal also you have to say. So that SF and XOR with the OF sign flag and the overflow flag with 0 and 1. So these two JL and JGE are working. JL in the sense jump on less, JGE in the sense jump on greater or equal. Same way, these two opposite side of jump on less or equal, or jump on not greater. Jump on less or equal, or jump on not greater. Again, jump on greater or jump on no less or equal. It means that it is a greater. So in that two types also you have to use the XOR plus with the zero flag. Plus with the zero flag you are going to be used. So all these are jump conditional statements, JC statements. Okay. So clear explanations also I have to given. Please all of you go through with that. So these today's I think jump instructions, under that jump instructions I have to given you uh, 10 with minimum 16 to 17 instructions in the jump. So these are not very rare you are using, but as per syllabus you have to please study all those instructions. So dear all students, uh, next one more call instructions is there. So we don't go too much. Okay, very
Hello,
slow. Yeah, please.
sir. When you do practical on the instructions,
Actually, we will start today only. Actually, I am waiting for the practical because some more instructions. See, up to today, I have to given you this much jump on conditions. So after that, some call unconditional instructions are there. So after that, some intra segment that is fair call instructions, and some return instructions are there. So some and this push up, all these are covered. So actually, to complete these instructions, again, 1 or 2 lectures I need. So actually, once you come to know all the instructions, actual program we will start. But up to again, just you wait for 1 or 2 lecture, because once you completely understood all the instruction, these instructions only repeating in the program. So once you perfect with these instructions, and these instructions you have to use it in the program, in the practical, that time real working functionality of instruction you will get to know clear. Okay. So just again 1 or 2 class you be wait. But today one small program I have a plan to execute. Just one small program I have to plan execute. We have to execute it. We'll just check it out. Okay. So today up to now this much I have to cover up to jump conditional instructions. So till in the sense Okay. So again, please you wait. Again, this one more topic I have to cover. That is okay. Again, so many are there. So okay, one by one we will see. So these are the only instructions only. You go and turn the page in my notes. So this again minimum takes 1, 2, 3. So dear all students, this theory part, just this theory part, I'll stop it here. Today's what are the things I taught you? Just I taught you input and output addressing modes, that in and out, and I taught some execution instructions like intersegment direct and indirect, intersegment direct and indirect, and also I taught some jump conditional instructions. JC means jump conditional instructions we have to taught today. So it's okay for the today's lecture. So after this, I will move to program part. Just today, one, how to add two numbers. How to add two numbers. I'll give you the program. So at the beginning, you may understood or you may not understood. Don't feel bad. So it's the first program I have to give unto you. All of you now open your machine, that is TASM. All of you installed TASM software, right? Please reply me.
Yes, sir.
Yes, sir.
Okay. Yes, fine.
Yes, sir.
So one sample program we will execute. Just we will execute, because this is the beginning step of practical session. Just we will either you understood or you may not understood. Not a matter. But today you have to learn how to execute a microprocessor program. Okay. I will teach you how to execute microprocessor program. Last in last session, one session we had a session on that, how to install and how to use the commands. Okay, just we will install the TOSM software and we will use the four commands. That is edit command, next one is TOSM command, next one is objective command, TD command, and execute command. So totally four commands we have to study, right? So that is just for the installation and commands of the TOSM software. What we had a session on that last. So today we will have a session only for how to execute the program. One program I will give you, how to execute this program. Just we will study. We don't bother about program. First we will learn about how to execute the program. Once we learn how to execute the program and how to use all the commands in the TASM software, then we will go for to understand the program. Is it okay for all of you? So now I will stop my lecturing and I will go for practical session. Okay. So dear all students, uh, I will minimize these notes. Okay. So everything I am going to minimize. Yes, fine. Dear students, now I will move to the TASM software. So all of you have to visible on the screen. Yeah, my screen is visible to everyone, right?
Yes, sir.
Okay. So in that, I have a my TASM software at this position. All of you observed. So just I will click on that. So all of you have to go along with me in your machine. Just double click on this software if you are installed. If you are installed, you have double click on that. Please, if who are not installed, please you go and install today itself. By today onwards, we have a lab session every day. Every day, 1 hour or 1.5 hour lecture and 1 hour or half an hour lab sessions. Like that, we have to cover no onwards. So, dear all students, I just double click on this software, TASM. That TASM window is opening. Yes. So this is the TASM window. Okay. So this is the TASM window. So what is the first command? Please tell me, anyone, if you remember what I taught last. What is the first command used in TASM? That
edit
is
file name.
edit space file name we have to give. See, here the simple program, first program, just I have to use addition of two number. Addition of two number in the sense I have to use add. This is my name of the program, ADDD 3D I given add dot. What is the edit file? That is edit file name dot what?
ASM.
ASM. Only one student is talking. Please talk all the students because that session is over. Okay. First command is edit file name dot ASM. Edit file name dot ASM. By using this command, you are go to the edit command. So wherever your program is want to execute, in that you have to move it. That one we say it is a edit command. That one we have to say it is a edit command. So here just you have to press after typing this command. So I will press enter. That edit command window is opening like your C programming. That edit command window is opening. So here in this command window, that edit window, you start to type a program. So today, just you observe, you don't bother about program. Just you bother about how to type a program and how to execute a program. Today's task is how to type a program in the TASM software and how to execute a program. Only this much you have to learn. In the next practical session, I will teach you regarding particular program. Okay. So here I have to make, so this is entire part of the edit window. In that edit window, I have to divided it into two parts. One part is data segment. One part is data segment. GEM segment. NT segment. One part is data segment and another part I have to take. So here, so once I have to open the data segment. So four segment you studied, right? Data segment, code segment, stack segment, and one more is base segment. So here I am using data segment. All of you please remember. And after somewhere, I have to close this data segment. I have to close the data segment. That is data ends. So here I am opening a data segment and here I have to end with the data segment. This is the portion of data segment. Data segment means data segment beginning and data segment that ends. At the last end of data segment is data segment ends. After that, I have to use code segment. Code segment. All of you please carefully listen. Very important. Just how to write the fashion of awesome software. It is code segment. Code segment. So after you have to create a memory for the code segment. After that again you have to end with code segment. So how to end with code segment? That is code ends. That is code ends. So I have to created a two segment, data segment and the code segment. So all of you writing a C programming, at the first you have to use hash include stdio.h, right? In that you have to use void main or int main. In the int main you are using all the declaration data declarations, right? So in this microprocessor, mainly we have to use it on the screen data segment and the code segment. There are the two parts. Here I have to begin data segment and I will end with the data segment. After that, I will begin with the code segment, and after I have to end with the code segment. So here for the data segment and for the code segment, you have to declare at the first how you are going to declare. Assume, assume CS. What is CS? Assume CS with the colon. It means that what? CS in the sense what? It is a code. CS in the sense it is a code, and the DS. See, this is the DS. First one is the DS, right? Data segment. So DS in the sense what? It is a data. It is a data. Okay. DS. So because how you have to use it, hash include stdio.h in the C programming, same way you have to use it in the microprocessor. You are going to assume which one you have to make data segment, that is DS. DS in the sense what? Data. So whatever the data is comes, you have to declare it in the data segment. Whatever. So two part, data segment begins and ends, code segment begins and ends. So whatever the data is comes, that all the data you have to declare in the data segment, and whatever your program code is there, your program code is there, all code you have to write in the code segment. So here assume CS is a code. See, either CS you have to write first or DS you have to write first, not a matter. Anyone you have to write first. CS code, or you have to write first as DS data. After that you have to write CS code. Vice versa also possible. Anyone you can write first and anyone you can write next. Not a problem. It will correct. Okay. So this is like your has include. So instead of has include in the C programming, in the microprocessor, you have to use assume. CS means code segment for the code, and DS means data segment for the data. So data segment is used for to declare the data, whatever fixed value or whatever the data values are there, we have to going to declare it in the data segment portion, and whatever the code segment is comes, our actual program, our actual logic, we have to write under the code segment. Am I clear, all of you? Code segment and data segment. Very important. If you not getting now, only you question to me, because this is the beginning stage. Once you learn perfectly, then later on all the program concept is very easy for you. Just I am today format the structure of program. I am explaining you the just execution of program. Okay. So this one you have to understand, in a program there are mainly two parts, data segment and code segment. This entire area is a data segment. It means that we have to declare the data, whatever useful data are there, we will declare it in the area of data segment. And whatever our logic is there, our program is there, that one we have to write in the code segment. Okay, so I think this one I cleared. And for the code segment, for the data segment, for the understand of the compiler in the machine, that's what we have to say to the compiler. The first line, what is that? We have to say to the compiler, hey compiler, हम कंपाइलर को बोलना चाहिए, क्या बोलना चाहिए? ये कंपाइलर, I am using a CS. That means you have to understand it is a code segment. हमारा काम है, हम उसको कंपाइलर को बोल देंगे. कंपाइलर को क्या बोलेंगे? CS मीन्स आप इसको समझाओ. क्या समझाए? कोड बोल के समझाओ. DS मीन्स आप ये समझाइए, it is data. So wherever that DS is comes, that is the data. Wherever code is comes, that is a CS. Okay, so this is the part. So in that part, again, I will come to the area of data segment. In that data segment, I am going to declare some values. So one register I have to declare, register A with the data word DW. So how in the C programming you are declaring that is integer a, right? So int a means what? A is the one of the variable which is of the type of integer in the C programming. So here also we have to declare there is a one data word of the variable a, one data word of the variable a, which is having a value of 1191h. Okay, 1191h. So how it looks? So here in the comment line, it is just like a int a equal to int a equal to 1191h in the C programming. In the C programming, this is declaration, right? 1191 hexadecimal value is assigned to the variable a, that is of the type of integer. Am I right? Same meaning it will give here. A is a variable which is a data word. Data word. So here we are using integer in the C programming, but in the microprocessor we have to use data word DW, which is having that the value of 1191h. Okay. So in the second line you have to write, take one more variable. The variable name is b with the dw, that is data, which is having a 2272. One sample value again I am taking. So these two are the value I have to take. A register, so we have to use the variable in the C programming, but here we have to use register. And here data type we are using a integer data type. Here in the microprocessor we are using data word as a data type. So data word as a data type is having a that one variable called a register A, which is having a value of 1191h. Same way in the register B. Okay, got it this point? So after that, what I have to do? I am going to do the addition of these two numbers. There is a 1191h, one hexadecimal number is there, and 2272h, one more hexadecimal number is there. These two numbers I am going to add. For that, I am using one more variable name as a sum, which is the data type again DW, because A is a data type DW data word, B is a DW data word. So automatically the result, the addition of result is also we have to get in DW. So the sum is DW, which is how much value we have to getting, that that one we have to use the question mark. That one we have to use the question mark. So dear all students, data segment, in that data segment what we did now, we have to declare the data to the particular variables of taking a particular data type. That's what this entire area we called it as data segment. The entire this area we called it as data segment. Got it? This is the main functionality of data segment.
Hello, sir.
So, yeah.
Sir, what is the purpose of DW?
Purpose of DW is nothing but it is a type of data. So in the C programming you use integer, right? Integer means what? All the integer numbers you have to take in. So here we have to taking data word. Data word in the sense, so whatever the hexadecimal number, decimal number, octal number, binary number, or any kind of text, whatever these all we called it as a data word, because all we call it as a word. What type of word it is? It is a data word. So for that, the implementer, how they used int instead of integer int in the C programming, like that in the microprocessor, the implementer they are used DW. It is a data type. Got it?
Yes, sir. Got it.
Okay. This is a data type. So here we have to use the variable a. We also we have to use the variable a. But the declaration fashion is different. At the C programming, first we have to use data type. After that, we will use the variable. But in the microprocessor, first we have to use the variable. Actually, we don't call it as a variable in the microprocessor. Actually, these are the registers. Registers are nothing but what? These are the memory locations. So that data, so this 1191 data you have to store in the memory register A. Memory register A, that's what that memory is going to be declared at the first in the declaration part. I think I cleared your question. Same way in the B register. Okay. So and one more some variable in the sense what? One more register we have to take. In that register, we have to store the result. That register I named as a sum, and with the data word only, because A is also a data word, B is also a data word. So again the result is comes A plus B is nothing but a data word only. So that data word, but still how much value we don't know in the data segment. That's what we have to keep the question mark. This is the passion of how to declare the data in the microprocessor. This passion is fixed. That's what all these I have to kept in the data segment. So all of you please get clarified this. अभी आप ये सब लोगों को समझ में आया. Later on easily you have to understood. Okay. So this is also one comment line I have to given that its meaning is int. It may be a float, char, whatever you have taken, because the complete number. That's what I am taking. Int b equal to 2272H. That is the meaning. It is in the C programming. Same this passion we have to use it in the microprocessor. This passion. So this is the entire data declaration part. Okay. So once you have to declare the data, next we'll go to our program. Next we'll go to our program. How to write the program? How to write the program? Next I'll move to the program. So here this is the starting point of code. Yes. Any question? I
When
have,
take
yeah.
float, then it also data word.
Yeah, please, I didn't get you. Please repeat the question.
When we take float, then it also comes in data word.
10th load.
Float.
Please text me a message. Maybe network is down in your side. So please text me a message. I'll look into that. Yeah, please. Is there any other students have any other questions? Please raise the question and ask. But these things you must and should get clarified it. आप डरना मत. क्वेश्चन पूछने के लिए कोई भी डरो मत. Please feel free and frank. You have to ask the question to me. Yeah, please. I'm waiting your text.
Check chat box.
Chat box. Please don't go to chat box because I have to open the software. If I want to go to chat box again, I am close to the software. So please, through the WhatsApp, you text me a message. Just 1 minute. Because this window I close, it means then only I have to get the chat box in the Zoom.
Sir, I said when we take float instead of integer, then it also comes in data word.
Yes. Okay. Yeah. I got your question. So instead of integer, if we have to use a float number, that is also used in the DW. Your question is right.
Yes, sir.
Okay. So see, as I already told you at the beginning, only I told you the microprocessor only knows the binary numbers. So for that, you don't use the decimal number. Decimal number in the sense what? Fraction numbers are the 11.91H. Like that, you don't take. That scenario is not accepted in the microprocessor. Complete number only you have to take, because H in the sense what? It is an address. It is a memory address. Memory address is not in always it is not at all in the fraction point. That's what you don't use the float. So here This integer and float you don't use at all in the microprocessor. Just for your understanding purpose, I compare this data value with the C programming. That's what I have to put in the comment line. Semicolon means what? It's a comment line. So otherwise, I have to remove this line. So better you are getting confusion. I have to remove this. Okay. So,
Now
so
got it.
just for your understanding purpose, I have to mention in the comment line. Okay, fine. So this is the fashion. Always you have to use the DW only. DW is nothing but data word only you have to use in the microprocessor. So I think very good question. Very good question. By this question, I think everyone is get clarified. Okay, so this is the data segment part. Next, I will move to the code segment. I think I cleared your answer, right? So one maybe text I got in the WhatsApp. Yeah. Is it necessary to write after some DW? Yes, yes. See, after some you compulsory write the DW. Why means some is what? It is like a A or like a B. A is a memory location register. B is a memory location register. Some is also a memory location only. So whatever the value you got, addition of A and B, that value is going to be stored in the sum register. That's what you have to use DW. It is compulsory. It is compulsory. You whatever you are getting the output, that is data word only. Okay, that is data word only. Please reply me if you got. Okay, fine, thank you. So compulsory you have to use the data. Same A DW, B DW. Instead of C, I have to naming conventions. Some I have to use the one register, that is DW. This is also a DW because still in the data declaration part, we don't know the result. We don't know the result. That's what we have to put the question mark. This is the fashion of declaration. If we don't have any value. Okay. So yes, fine. So this is the declaration part. Next, I will move to the code segment. In the code segment, actual our program is starting from this point, so that's what we have to use start, start, start. How you are using main function in the C programming, no? How you using main function in the C programming, same way you have to use start in the microprocessor. So dear all students, only 10 minutes is remaining for me to end up my class. So just I will show you the execution. In next class, I will explain you this program. Okay. Just to observe how to execute the type the program and how to execute within a 10 minutes because time is very short. So entire this program I'll explain you in the my next lecture. Just all of you observe how to type the program and how to execute the program. So this is the fashion. Your code segment is start from this point. So here you have to write the program. Our instruction starts move AX comma data, move AX comma data. Next instruction, that is move DS. Don't bother about the program, just observe how to type and how to execute. Next instruction, move DS AX. One more register I have to take. After that, again move AX comma one memory register I have to take OC00H. It's the memory register. After that, again move comma AX, move AX comma. So that A register I have to take it here. After that, uh, move. So it is case sensitive. Either you use uppercase or lowercase, not a matter. Any case you have to use. Move BX comma B register, whatever you take in the data declaration. After that, what you will do, A and B manipulated, you have to add. Add is a one instruction. Later on, I have to explain you in the third unit lecture part. Add, what you have going to add? Add AX and BX. Add AX comma bx. You have to add. Up to that, you have to move. Where you are going to move? Move to the third variable sum. Move to the sum, comma, that ax register, sum ax register. Up to that, you take one integer value. So any number of integer, for example, I am taking normally 3. Up to that, I have to ends the code. This is the my program. After that, I have to ends the code segment, ends the code, and and at the last, I have to ends this start. So that is end start. So this is the one simple program to addition of two numbers. So here I am somewhere I am using capital M, somewhere I am using small m. There is a no case sensitive, either capital or small, uppercase or lowercase. You have to use not a matter. Here you have to declare some as a capital. Here you have declared some as a lowercase. Also, it is acceptable. Okay. So dear all students, this is the one program declaration of two variables here, three variables. One is the result variable, and this is the program. Just don't bother in this code. I'll explain you in the next lecture. Just you have to go for how to execute it. So dear all students, so what you will do after this, you go to here, save the program, go to the file. After typing is completion, go to the file, save the program. So that program name is tasm add.asm. This is our program, right? What's the name of the program? add.asm. So save this program, go to exit and use the third command. So what is third command? Please tell me. What is third command? tasm space name of the file dot asm. This is the second command, right? So is it a second command?
Yes, sir.
So what it will give, see, all of you listen here. Your assembly linking file is add.asm. It is giving correct right output, and warning is none. Errors is also none. It means that our program is correct. There is no error messages. There is no warning messages, and passing the one value means our program is going to be correct. Next, we are use the third command. What is the third command?
T-link
T-link
our file name dot
space
obj
file name
dot
dot
obj.
objective file. You are going to be given the T-link with objective. That's what obj. Very good. T-link add dot obj, file name dot obj. So here that is turbo link version 2.0 copyright. That is also giving a complete. So warning, it is giving no stack. No stack means still our program is not started, or will not get any memory. For that, what we will do, we have to use the executable file. So what is last command for the executable? It is td
td our file name exe dot
file
exe.
name add.exe, right? So
Yes,
dot
sir.
exe. So go and check it. Just press the enter. You will get it this window, right? So in this window, program has a no symbol table. So for that, you just click the OK. You just click the OK. After that, you have to check this value. You have to check A and B register. You have to go and add. You have to go and add. Then you will get correct output. So here, what you will do? You go to run. See, this is the one run option. To go to run, click on that run. Click on that run. So you will get the value of. You will get the value of, see, ax. What is the you go and check it. Are you getting this much value? 3403.
Yes, sir.
So this is the way of how to execute the program. Dear all student, in the data A we have to take 1191, right? For the A register, we have to take 1191 in the data segment and B register 2272. So all of you are add by using the hexadecimal calculator 1191H and 2272H. So by adding these two, you have to getting this number. Go and add, and are you getting this number? If you are getting this number, means our program is correct. So all of you got it. So this is a screenshot all of you took and try in your home. So just dear student 3403, all of you remember, I'll show you this result in the Google. Okay. So got this output, all of you?
Hello, sir.
Yeah, please.
Please back.
Yeah, please. What? Hello.
Sir, our command command slide, sir.
Command slides. So command slides again. I am coming from beginning.
No, sir. When we add dot sam means or some command now use no.
Okay, 1 second. I will come. Yes, which one you are saying?
सर अभी आपने जो प्रोग्राम रन किया उससे पहले आपने कमांड यूज किया था
अच्छा
मीन एडिट add dot sm and
okay, those commands you need.
yes sir.
Okay, better I will close this and I will reopen. Okay, just 1 second. So because time is over. Okay, anyhow, 1 or 2 minutes I'll take. It's fine. So this is the command window. So dear all student, first command is edit file name. Our file name is asm. This is our file name, right? If we edit file okay, dear all students, because next lecture yeah, please. You text me a message in your doubts. Also, all the things I will explain you, whatever today's lab session I took, same session I will explain in the next lecture. Don't worry. Okay. This is a beginning step. We have to learn perfectly. Again, all this practical session, whatever today I explain, same way I will explain you in the next lecture. Please don't feel bad, all of you. Please you go and join to your next lecture. Thank you one and all.